Hello everyone. Good evening to all of you. Let's wait for some time so that other students can also join. Hello, hello. Good evening. Good evening. I hope your exam goes pretty well. I think this was a typical JEE mains paper. So this time you might not be able to solve that much questions, but yes, you will learn from this question paper very much. Because almost variety of questions were covered in this paper. Okay, so one by one we'll understand what were the concept we were lagging. Okay, so that we can absorb that one, and at the time of in the next mock test we can solve those kind of problems contain that kind of concept. Okay, so with that, we'll start. Just we'll wait for a couple of minutes more so that other students can also join. Maximum number of students can join. So you guys can tell me how was your paper? Like how much you were able to score out of 100 in mathematics only. Just wait for some time. Meanwhile, you can prepare with your pen and paper and get ready for the session. Okay. Okay, so I have launched a poll. You can fill the answers if there is any problem with the video or audio or screen, you can tell me. Okay. Guys, just wait for 1 minute. Then we will start the session. Okay, so now we'll start with the first question. First question is saying integration we have to find out. Integration of e to the power x this into this function. This is some horrible function is there. Okay, so we have to simplify such that we'll get one of the options which is possible. Okay, so here what is the understanding with this problem. The problem itself, whenever we see e to the power x inside the integration, first thing comes in our mind that integration of e to the power x fx plus f dash x dx is equals to e to the power x fx plus c. If you remember this formula, you can solve this problem. Okay, so this one is important formula you need to remember if you forgot. Okay, to solve this problem. Okay, so let's start. So here we have to simplify this whole function as in terms of fx plus f dash x, right? That is how we can, if we are able to do that, then we can directly write the answer, right? So what I am doing, if you can see in the numerator part, there are three terms: 1, 10x to the power 9 and minus x to the power 20. Okay, and in the denominator, every term is in every power of x has 10 or 20, right? So if I try to write in terms of two functions, f and its derivative, then what I'll do, I am taking 1 minus x to the power 20 on one side, I'm clubbing them, and I'm writing the third term separately. Okay, and at the last in the denominator I am writing the same thing. So 1 minus x to the power, sorry, it is 10 times root over 1 minus x to the power 20 dx. Clear? Now, why I have taken these two terms only and clubbing them? Because in the final answer you can see in the denominator part, if you see, then the power of x is always 10, right? So I have to write in terms of fx plus f dash x. So clearly this comes out as f dash of x to the power 10, right? That means that right part side can be of f dash x. Clear? So now I am separating them. So in the first part, what I'll write, 1 minus x to the power 20. Now you can see x to the power 20 can be written as x to the power 10 whole square, right? So basically what I'm doing, I'm going to use a square minus b square formula. So which can be write down as 1 minus x to the power 10 times 1 plus x to the power 10. Clear? So with that, I can write 1 minus x to the power 10, which will be cancelled out in the denominator if I try to separate. So only part what I am writing, 1 plus x to the power 10. And in the denominator, only 1 minus x to the power 20 will be there. Then plus. I'll write down the second part as it is. So 10x to the power 9 divided by 1 minus x to the power 10 whole multiply with in the denominator 1 minus x to the power 20 dx. I think this part is clear. Now I have to make this function as fx and try to convert this into f dash x, so that my answer will be e to the power x into fx. This is the funda. Okay. So what I'll write, e to the power x. Now this can also be simplified because this is again x to the power 20. So I can write in terms of 1 minus x to the power 10 times 1 plus x to the power 10. Okay. So what will happen? In the numerator, I will write 1 plus x to the power 10 upon root under root of 1 minus x to the power 10 into 1 plus x to the power 10, and plus rest of the things are as it is. So I have written this again. I hope till now there is no problem. So now what I'll do, now I will simplify again my fx. So now you can see 1 plus x to the power 10, and in the numerator 1 plus x to the power 10 is there. So basically the numerator is the square of the denominator part for 1 plus x to the power 10, right? So what will happen? 1 root will be there if I cancel, because this is same like x square upon x, or x upon root x, right? So root x will be there. Clear or not? So I hope you understood this point. So what I am doing, I am writing in the numerator 1 plus x to the power 10, and in the denominator 1 minus x to the power 10 and whole under root, because under root of a upon under root of b is under root of a upon b, plus rest of the thing is same. So 10x to the power 9 upon 1 minus x to the power 10 under root 1 minus x to the power 20. Clear? Cool, no problem. Now e to the power x. Now I have to now check which function is fx, and with respect to that which will become f dash x, right? So as I clearly mentioned you that 10x to the power 9 is something of x to the power 10 differentiation. So this might be my f dash x, and if this is f dash x, this should be my fx. So I have to recheck whether for this fx this term is f dash x or not. So in the next page I'll assume let fx is equals to root over 1 minus x to the power 10, sorry, 1 plus x to the power 10 upon 1 minus x to the power 10. Okay, now what we'll do, we'll differentiate. So same basic formula. This first of all I have to assume this as root of function. Okay, so I'll treat it as root x. What is the differentiation of root x? 1 by 2 root x. Okay, so 1 upon 2 root x. So root x means this term again. So root 1 plus x to the power 10 upon 1 minus x to the power 10. So what I'm doing, I'm taking that part in the numerator because it will flip it. Okay, so I am writing in the numerator 1 minus x to the power 10. I hope this point is clear till now. Okay, so what we have done, we have differentiate this function, and now using the chain rule we have to differentiate the inside function. Okay, so I should write this as f, not f. I should write this as root fx or root gx, so that you won't be confused with both f. Okay, so first of all, what is the differentiation of root gx? 1 by 2 root gx into differentiation of gx, right? So into differentiation of gx means this function. So this function is actually numerator upon denominator means fraction function, and whenever we see fraction function, what we do, we use quotient rule of differentiation. So what is quotient rule of differentiation? Let's say if two function hx and wx are two function, then what will be the differentiation? the differentiation will be h dash x into wx, means differentiation of first into second function minus differentiation of second into first function whole divided by denominator square, means wx to the whole square. So I'm going to use this. So differentiation of first function is numerator. So what is the differentiation? 10x to the power 9, because 1 is constant, so constant differentiation is 0, into second function 1 minus x to the power 10 minus differentiation of second function. So one differentiation is 0 and minus x to the power 10 is minus 10 into x to the power 9 whole multiply with first function. So 1 plus x to the power 10 whole divide by denominator square. What is denominator? 1 minus x to the power 10. So 1 minus x to the power 10 to the whole square. This will be my f dash x. Now I have to simplify this. So what will happen? Now here you can see minus and minus will be plus. This and this minus will become plus. Okay, this is in bracket. Now, so what I'll do, I'll first of all write it as it is. So 1 minus x to the power 10 upon 2 times root over 1 plus x to the power 10 whole multiply. This will become plus. Now you can see this from this and this term 10x to the power 10 is common, right or not? I'll use different color. 10x to the power 9 is common. So what I'll write, I'll take out 10x to the power 9 common, and in the bracket part, what I'll do, plus sign between them. So 1 minus x to the power 10 plus 1 plus x to the power 10. What will happen? Minus x to the power 10 and plus x to the power 10 will be cancelled out. So 1 plus 1 will be 2. Whole divided by 1 minus x to the power 10 to the whole square. Now you can see 2 and 2 is cancelled out. So we are getting f dash is equals to, now this can also be written as 1 minus x to the power 10 into 1 minus x to the power 10. X square, basically x into x. So what I'm doing, root 1 minus x to the power 10 into 10x to the power 9 I have taken forward, divide by 1 plus x to the power 10 into 1 minus x to the power 10 and 1 minus x to the power 10. So what I'm writing, I'm writing 1 minus x to the power 10 whole square and taking root. This is same thing. Okay, so what will happen? 1 minus x to the power 10 and 1 minus x to the power 10, numerator and denominator is cancelled out. So only one power is there with a root, right? So finally what we are getting, 10x to the power 9 divided by 1 minus x to the power 10, and in the denominator under root 2 terms are there. 1 plus x to the power 10 multiplied with 1 minus x to the power 10. So this is 10x to the power 9 upon 1 minus x to the power 10 whole multiply. Now a plus b into a minus b. So I'll directly write a square minus b square. Now you can check this is our f dash. So let's see whether this is f dash or not. So in the previous part, 10x to the power 9, here 10x to the power 9 upon 1 minus x to the power 10 into 1 minus x to the power 20. 1 minus x to the power 10 root 1 minus x to the power 20. Clear? So we have cross-checked that if I have assumed that one as fx, then this second term will be our f dash x. So final answer what we'll write, e to the power x into fx. So fx will be root over 1 plus x to the power 10 upon 1 minus x to the power 10 plus c. This will be my final answer. Clear? So now check which option is correct. So option number root part is there. So C and D might be possible, and in the numerator 1 plus x to the power 10. So this part, option C is correct. Clear? Understood? Basic fundamental was, if e to the power x is there in the integration part, try to convert it into fx plus f dash x. Try to write function as fx plus f dash x and cross check what function I should, and check which function I should treat as fx, so that the other function will be treated as f dash x. And final answer will be e to the power fx, e to the power x into fx. Clear? Easy question. I don't think that should not be solved. Okay. And also this type of question already solved in numerous times in class. Okay. So with that, we'll move ahead. Okay. So I have taken all the questions in one sheet so that we'll solve it on one by one. Okay. So question number second. So I'll solve 60-second question here. Okay, so basically what is given here, some equation is given in x and y, means function of x and y is given, and we have to find y double dash at which point 1 minus 1 comma 1. I think this is very easy question. This is MOD question, right? So what we have to do, we have to double differentiate this equation, and we have to satisfy 1 minus 1 comma 1 on that equation and check d2y by dx square of y double dash. Clear? So what we'll do, we'll simply first differentiate this equation. So e to the power x plus y, I treat it as, let's say, t. So x plus y is t, then what is the differentiation of e to the power t? So same thing, e to the power t only, and into differentiation of t. What is t here? X plus y. So if I'll assume, then e to the power x plus y into differentiation of x plus y, d of x plus y I am writing so that you can easily understand, is equals to differentiation of y square, because we are differentiating both sides. So 2y dash. Wait a minute. 2 2y dash is there. Okay. Now I'll first solve this differentiation of x plus y. So differentiation of x is 1 and y is y dash. So e to the power x plus y into 1 plus y dash. I think there is some lag. Into 1 plus y dash. Wait a minute. I'll solve it on next page. Okay. Okay. So the question is e to the power x plus y is equals to y square. So what we are doing, first of all, we are differentiating with respect to x. We have to find y double dash at minus 1 comma 1. Okay, this we need to find out. So what we'll do, e to the power x plus y into differentiation of power function. Okay, so power function differentiation is 1, x differentiation, and y differentiation is y dash, is equals to 2y dash. Clear? Now what I'm doing, I'm directly also putting the value, the point here. Okay, so point is minus 1 comma 1, means x is minus 1 and y is 1. So e to the power minus 1 plus 1 into 1 plus y dash is equals to 2 into 1 into y dash. So we are getting e to the power 0, which is 1. So 1 plus y dash is equals to 2y dash. So here we are getting y dash is equals to 1. Clear? Now what we'll do, with this information, we are going to find out double differentiation. So this was our differential equation after differentiating first time. Okay, so I am again differentiating with respect to x. Okay, so what we will get now, first of all, what we should do, actually we can remove this e to the power x from original equation. So I am writing e to the power x plus y as y square into 1 plus y dash is equals to 2y dash. Now I am differentiating. So I'll write it again and remove this part. Now differentiating with respect to x. So we are going to differentiate. So first we can also separate it and then differentiate it. So y square is there. Okay, so y square differentiation is 2y dash plus y square y dash. So again product rule is there. Okay, so y square differentiation is 2y dash into y dash. So y dash whole square plus y square into differentiation of second. So y double dash. So y square into y double dash is equals to 2. Again product rule, y dash into y dash. So y dash square plus 2y into y double dash. Now we will substitute the value of y dash. So 2 into 1 plus 2 into 1 into 1 square plus 1 square into y double dash is equals to 2 into 1 square plus 2 into 1 into y double dash. Clear? So here we are getting 2 plus 2 plus y dash, y double dash is equals to 2 plus 2y double dash. So 1 2 is cancelled out from both sides. So we are getting 2y double dash minus y double dash. I am taking this y double dash to the right hand side. So y double dash is equals to 2. This is my final answer. So let's check which option is correct. Option number A is correct. Easy question. We could have easily solved this in examination, right? Moving on to the next question. So question number 63 is saying let cos alpha, sin beta, and sin alpha are in increasing GP. Then find the roots of x square plus 2 cos beta x plus 1 is equals to 0 are, where alpha and beta both are real numbers. Okay, so now we'll try again so that there is no lagging. I'm going to solve here. So 63, these three terms are in increasing GP. Okay, so increasing GP means every next term will be more than the previous term, right? So we already know that in increasing GP, R should be positive as well as value of R should be greater than 1. That is how we are going to make an increasing GP. Clear? So also these three terms are in GP. So what we can write, middle term square is equals to product of first and last term, right? Because if A, B, C are in GP, then we write B square is equals to AC. So I'm going to use here. So I'm going to write sine square beta is equals to cos alpha into sine alpha. Oh, and whenever we see cos alpha into sine alpha, what we do, we'll multiply both side by 2 or we'll multiply and divide by 2. So I am multiplying on both sides. So we are going to write 2 sine square beta is equals to 2 sine alpha cos alpha, which is sine 2 alpha. Yes. Further, what we can do now, this is, let's say, R one information. Okay, now with this we are going to find out the root. So what the examiner is asking, it is asking about nature of roots, whether they are real or distinct or real, or it is also asking us to find whether both are positive or negative. Okay, so clearly we can see here uh, for the roots, if they are positive or negative, here you can see product of the roots is 1. C by A, right? It means both are positive or both are negative. right? So might be possible that both are positive. Now we had to check whether sum of the roots is positive or not. Okay. So sum here we are getting minus b by a. So minus 2 cot beta. Okay. We already know that this is increasing GP. Increasing GP means term will the coefficient, sorry, the common ratio will be positive and greater than 1. Hmm? Okay. Also, alpha beta can be any real value. Okay, so what we'll do, we'll try to check later. First of all, we'll check whether what is the nature of root. Nature of root means we are talking about d, whether it is greater than 0, less than 0, or equal to 0. Okay, so d from the given quadratic equation we can write v square minus 4ac. So 2 cot beta whole square means 4 cot square beta minus 4ac. So 4 is common. We can write cot square beta minus 1. Okay, cot square beta. Okay, no problem. So for cot square beta, what I'm doing, we are going to write in terms of sine cos, because we are getting here in terms of sine cos only. Okay, so cos square beta upon sine square beta and taking LCM simultaneously. So minus sine square beta upon sine square beta. Clear? And whenever we see cos square beta minus sine square beta, and then what we can write? We can write this as cos 2 beta. Okay, so we can write 4 cos 2 beta upon sine square beta. Clear? Or we can also write this as 4 into what I'm trying to do is 4 into cos 2 beta upon sine square beta. Okay, no problem. Then we'll see what information is given. 2 sine square beta is equals to sine 2 alpha. Okay, so 2 sine square beta. 2 sine square beta means 1 minus cos 2 beta. Okay, so I can also reuse it 1 minus cos 2 beta, because that is how I can substitute the value of cos 2 beta is equals to sine 2 alpha. So here cos 2 beta will be nothing but 1 minus sine 2 alpha. Okay, so I am now going to substitute this value here. So 4 into 1 minus sine 2 alpha upon sine 2 alpha. Clear? Any doubt till here? Okay. Now you can see that I told you that every next term will be positive. Okay. So sine beta should be positive. Sine alpha should be positive. Right? Also cos alpha should be positive. That is how we are going to make an increasing GP. Let's say if cos alpha is negative and sine beta is positive, then the ratio will be negative. Right? Positive upon negative is negative. So which is not possible because we have to make an increasing GP. So now you can see that sine alpha, every angle is for every angle trigonometric is positive. So what I can do here, I can write this. I have to think whether this is positive or negative. So sine alpha is positive. Cos alpha is positive. So what about sine 2 alpha? Sine 2 alpha is 2 sine alpha cos alpha, 2 sine alpha cos alpha. If this is positive, cos alpha is also positive, then clearly sine 2 alpha is also a positive number, right? Also, cos alpha will be lesser than 1. Sorry, sine 2 alpha will be lesser than 1. Okay. So here you can see that 1 minus sine 2 alpha will be positive and sine 2 alpha is also positive. So that means this whole term is positive, which means we can say that D is positive. Right? D is positive means real and distinct roots we are getting. Clear? So option A is correct. Why? Because Obviously this is JEE mains paper, so we have to check only one option. Clear hai? Should we move ahead? Okay, so what we will do, we will go on to the next page for the next question, question number 64. Okay, here we will solve it. I'll dictate you the question because I know that there is already messed up. So what I'll do, I'm trying so that this part can be. Okay, cool. So I can now read this question. So question number 64 is saying that A is the number of permutation of n different things. So permutation and combination question is there. This question is also very easy question. We could have easily solved this question in a minute. Okay. So question number 64 says that if A denotes the number of permutation of n different things taken all at a time. What is the number of permutation of n different things? N factorial. What does that mean? What does that mean is if there are n places and we have to arrange n people at a time, then we have n factorial possibility, right? So we can clearly found our value of A. So value of A will be n factorial. Okay. Now next statement is B is the number of permutation of n minus 2 different things. So we have to arrange n minus 2 different things taken 10 at a time. So what we'll do, first of all, we will select 10 things because we have to arrange only 10 things at a time. Okay. So first of all, we will select 10 people out of n minus 2 people in, and then we can arrange them. So because permutation is there, so selection plus arrangement is there. So two tasks we will do here, like we have done in first part. So we will write B is equals to, first of all, selection of 10 people out of n minus 2 and then arranging them. Arranging them means factorial 10 ways, because 10 people can arrange in 10 places in factorial 10 ways, which is nothing but NC2P10. Remember, NCR into R factorial is nothing but NPR. So we can use this directly. We can also write this. Okay, so NPR, what is NPR? NPR is nothing but n factorial upon n minus R factorial. Okay, so here we can write n minus 2 factorial upon n minus 2 minus 10. So n minus 12 factorial. Clear? Now we'll move on to the again. What is again it is given. C is the number of permutation of n minus 12 different things taken all at a time. So this is same as the first case, because number of permutation of n different things or n minus 12 different things taken all at a time means factorial of that number. So C will be n minus 12 factorial. This is the arrangement of n minus 12 people in a line. Okay, now what is given, and it is given that A is equals to 182 BC, then find the value of n. Okay, so we have found already ABC. Now we will substitute in the equation. A is equals to 182 BC. So A is n B. B is n minus 2 factorial upon n minus 12 factorial multiplied with C. C is again n minus 12 factorial. So this is cancelled out clearly. Now n factorial is there and n minus 2 factorial is there. Whenever we see this type and both side equal sign is there, that means they are going to cut down. How? We know basic formula is n factorial is nothing but n into n minus 1 factorial. So using this identity, we are going to solve. So what we can write, n factorial is n into n minus 1 till n minus 2 factorial. That is how we can cancel. And 182 times n minus 2 factorial. So n minus 2 factorial, n minus 2 factorial is cancelled. And in the next page, we can write that n into n minus 1 is equals to 182. 182, what we can do, we can prime factorize it. So we can prime factorize, but clearly this is divisible by 2. So 2 into 91, and 91 again in terms of table of 13 or 7 we can write. So 13 sevens are, or 7 13s are. Why I am doing it? So now I can write in terms of n into n minus 1. See, so directly by analyzing we can find out the value of n. N into n minus 1. One number and lesser than one number. One number and lesser than one number. So clearly n is equals to 14 will be the only possible answer. Right? So n is equals to 14. Option number C is correct. So now with that 4 questions, you can see that how questions were easy from this exam. Question number 61 was moderate, let's say, but 62 was very easy. 63 was, let's say, moderate again, but 64 again is very easy. So out of these 4 questions we could have solved easily, very easily 2 questions, right? Now moving on to the question number 65. So let's read it first. In a test examination, either guesses, copies, and knows the answer to a multiple choice question with 5 choices. Okay, examinee is there, and he have 3 choices. Either he can guess the question, guess the answer to the particular question. Either he can copy or he knows the answer. Right? Logically, if we have any 3 choices to answer a particular question, either I can guess, or I can copy from someone, or I can solve myself. So we know that we should solve if we are able to do it. Okay, with 5 choices. So the question is saying that in that question there are 5 options are there. For a multiple choice correction there are 5 choices, means A, B, C, D, E options are there. Option A, B, C, D, and E. These are the 5 choices, out of which I have to select one choice to get my answer. To get my correct answer, probability will be 1 by 5, or chances will be only 1 out of 5. Right? Now, the probability. So clearly this is a probability question. The probability that he makes a guess is 1 by 4. Okay. So let's write this in a, again, next page, question number 65. 65, what it is saying, that we have 3 choices to solve a question with 5 choice in that question. A, B, C, D, E, 5 options are there, and probability to make a guess is 1 by 4. So let's say I am assuming that probability, that event to be G. G for guessing. So probability of guessing is 1 by 4. This is the first thing given in the question, and the probability that he copies the answer is 1 by 8. Okay, so second event is copying. So I am assuming that event as C. So PC is 1 by 8. This is for guessing and this is for copying. And the next is the probability that his answer is correct, given that he copies, is 1 by 10. What is given? Probability of answer is correction is given. Correct answer probability is given as 1 by 10, given that he copies. Means conditional probability is given. P A given B. Remember in the last mock test, the same kind of questions were there. Was there? Okay. So what is given? P, let's move back. Probability of his answer is correct. So correct answer I am assuming as CA. CA is correct answer. Correct answer given that he copy means C event is equals to 1 by 10. This is given. Okay. What he is asking, find the probability that he knows the answer to the given question, to the question given that he correctly answered it. So we have to find out the P of knowing. Knowing, let's say I am assuming as K. The event is K. So P knowing, given that he correctly answered it. This is what he is asking. Clear? So now what is the question? Question is we have to find P of knowing, given that answer is correct. This we have to find out. Okay. So ultimately what we need to find out, we can use the conditional probability so that we can write PA intersection B means knowing such that correct answer is also there upon PB. So correct answer probability. Now, so of course we can also use Bayes theorem. Okay, so what I'm doing, we can write PK intersection CA as P probability of knowing the answer given that answer, sorry, probability of correct answer knowing that answer given that he has used knowing choice, okay, into probability of K whole divide by correct answer. Correct answer can be given in three ways, whether it can be using guess, whether it can be using copying, or he might know the answer. So probability of correct answer given that he has used guess into probability of G plus probability of correct answer given that he has copying into probability of copying plus probability of correct answer given that he knows the answer into probability of knowing. This is what we need. Okay, so probability of correct answer given that copying is given, this part is given. Okay, so only three events are there, C, G and K. So we can find PK. How we can find? Because we know that in probability how many, whether the number of events are given, whatever the number of events are given, the sum of the probability of all the events should be equal to 1, right, for any experiment. So PK plus PG plus PC should be is equals to 1. So PK can be write 1 minus 1 by 4 minus 1 by 8. I hope this part is clear to you, very much clear to you. I am using sum of all the probabilities of an event is of an experiment is equals to 1. So this can be write as 1 minus, this is 3 by 8. So finally we are getting PK is equals to 5 by 8. Clear? So PK is all out. Now we have to find probability of correct answer given that he has guessed, probability of correct answer he knows the answer. Okay, so first of all, probability of correct answer, he knows the answer. If he knows the answer and he has corrected it, logically this is a sure event, right? If he has corrected the answer and given that he knows the answer, if he knows the answer and he corrected it, simply that means that it is 100% going to be true. That means P of correct answer, probability of correct answer given that he knows the answer will be equal to 1. Why? Because this is a sure event. This is clearly logical, right? Now P of Now we will find P of correct answer given that answer is guessed. Okay. If you remember in the question, there was 5 options, right? How many ways I can guess the answer? There is one choice I can guess the answer. How out of how many choices? 5 choices. What will be the probability that I'll get the correct answer? 1 by 5. So 1 by 5 will be the probability of getting correct answer, given that I have used guessing method. So why this is 1 by 5? Because of 5 choices, I have to select only one. Select only one. Clear? And the last part is probability of C correct answer, given that he knows the, sorry, I think we have already done, yes. So we are going to use now. So PC given K, PC given K is 1 into PK. PK is 5 by 8 divided by PA given G. PCA given G is 1 by 5. So 1 by 5 into PG. PG is 1 by 4 plus PCA. Correct answer given that he copied means 1 by 10 is given into PC. PC is 1 by 8 plus correct answer. Probability of correct answer. He knows the answer. This is a sure event. So 1 into PK. PK is again 5 by 8. So now we can solve this. So in the numerator 5 by 8 is there, and in the denominator we can solve. This is 1 by 20, 1 by 20 and 1 by 80. So LCM is 80. So 4 plus 1, 5 by 80. 5 by 80 is 1 by 16. So 1 by 16 plus 5 by 8. So we can solve 5 by 8. LCM in the denominator is 16. So 16 will flip upon, in the denominator what we will write? We will write 1 plus 2 into 5, 10. 10 plus 1, 11. So this will be 8 to the 16. So 10 by 11 is my final answer. Oof, wow, we have finally solved it. So let's check which option is correct. 10 by 11 of question number 65. 10 by 11. Okay, let's check the option clearly. I'll remove, okay. I'll erase this part so that we can check. 10 by 11 is option number B is correct. Clear? I hope you understood every concept behind this. Any doubt till here? No? Should I move ahead? Clear? Okay, very good. So I'll now move ahead. So next question is question number 66. So in the question number 66, now we can see. So question number 66 is saying that the value of integration, again integration question is there, minus 20 to 20, minus 25 to 25. GIF is given. GIF of sine plus cos dx. Okay. So we'll find out new page and then we will solve integration of minus 20 pi to 20 pi bracketed of sin x plus cos x. Whenever we see bracket part, we have to break it whenever it values goes integer value, right? Remember this concept. So we have to break the function when it takes an integer value. So first of all, what we should do, we should simplify this function. So if you remember in trigonometry, we have found out that a sine theta plus b cos theta can be written as root over a square plus b square times sine theta plus alpha. What is alpha? Alpha is nothing but b upon root over a square plus b square. Okay, so here a is 1, here a is 1, b is also 1. So we can write sine theta plus cos theta as root over 1 square plus 1 square means root 2 into sine theta plus alpha. Now alpha I can find sine inverse b. B means 1 by root 2. So that this is nothing but pi by 4. Sine inverse 1 by root 2 means what is the value of sine theta when sine theta is 1 by root 2? You can think it in that way. Okay, so sine theta is 1 by root 2 when theta is equals to pi by 4. So we can write this now as root 2 times sine theta. Here actually theta is, instead of theta we should write x. Okay, x plus cos x. So here sine x plus alpha. So x plus pi by 4. Clear? So now we can write it as minus 20 pi to 20 pi integration root GIF of root sine x plus pi by 4 dx. Clear? Now I have to check on which points this complete value is an integer. We know the range of this function actually, because sine, this is sine of something, right? Something, let's say theta plus something. Okay, so this is can be treat as sine x, can be treat as sine x. How? Because here for in front of x there is only one. Okay, so this we can say the range of sine x is -1 to 1. Similarly, the range of sine of x plus pi by 4 will be -1 to 1, and we'll multiply with root 2. So what will be the range? Minus root 2 to root 2 close. So this inside function can take these values, and we have to take GIF of that and check on which values of x this function can take integer value, right? So what we will do, we can do it using graph. First of all, what we will do, we will simplify the limits. How we can simplify it? You can see this function is also periodic function. We have learned periodicity in function chapter. Okay, so sine x plus alpha, what is the period? Period is 2 pi. What is the sine 2x? What is the period of sine 2x? 2 pi by 2. What is the period of sine kx? 2 pi by mod k. So similarly here k is 1. So 2 pi by mod k means 2 pi. So this is a periodic function. Periodic function with period is equals to 2 pi. Why I am using periodicity here? Because with periodicity we can uh, simplify the limits. How? Period is 2 pi means whatever we are going to get the value in the region 0 to 2 pi, same value we will get 2 pi to 4 pi, 4 pi to 6 pi, as well as in the negative part means minus 2 pi to 0, minus 4 pi to 0, and so on. Okay, so what I'm doing, I can write this as integration. Now you can also use king property. King property means if minus a to a integration fx is given, and if it turns out to be fx, again applying the king property means f of a plus b minus x, if it is same as fx. So here a is minus 20, b is plus 20. So what is a plus b? A plus b is 20 pi minus 20 pi, which is 0. It means f of x is same as f of a plus b minus x. How? F of minus x, a plus b is 0. What is f of minus x? Okay, so here we can't write, sorry. Okay, no problem. Then we'll use only the limits. Okay, we'll not use king property. Uh, hmm, yes, I told you na, this is a periodic function, so value of function in 0 to 2 pi will be this, right? So what I'm doing, I am writing deliberately from 0 to 2 pi and check how many periods will be there between minus 20 pi to 20 pi. So let's say we'll break it from 0 to 20 pi and minus 20 pi to 0. Okay, so 0 to 20 pi, how many periods will be there? 10 periods, because each period is of 2 pi length. Similarly, in the negative case also, we are getting 10 periods. So overall, we are getting 20 periods. So 20 times 0 to 2 pi, we'll write root 2 times sine x plus pi by 4. I hope this part is clear to you. Now we will check on which values of x this complete function is an integer value, because this is a function which gives integer only. So we will break at which values of x this is an integer, and directly we can substitute that integer instead of this bigger function. Okay, so with that we'll be using graph. So graph will be easier to help us at which values of x this function becomes integer. Okay, so in the next page I am drawing the graph. So first of all, we'll draw only for 0 to 2 pi, right? Because we are going to multiply with 20 only. So with 0 to 2 pi, function of 1 by 1 we'll write down, because we know sine function graph. Okay, so sine function graph is this, right? From 0 to 2 pi. This is y is equals to sine x. Okay, now what we do, we'll try to find out the graph of sine x plus pi by 4. So if you remember transformation of graph, in the transformation graph, sine, let's say if f function of fx is, we know, graph of function of fx we know, then for function of f of x plus k we can draw. What does that mean? If function is converting from fx to f of x plus k, then what we do, we will translate the complete graph k units on the left hand side. What I'm saying, on the left hand side. So translate function by k units on LHS without affecting the width. We don't have to move out like upward or downward vertically. We have to only horizontally move it. Okay, so I should write here, translate means horizontally moving only. Horizontally move only. Okay, so here what we will do, how by how much amount we should horizontally move it? K is here is pi by 4. So pi by 4 we will shift on the left hand side. So the graph now we will be look like, so we'll draw the graph now for sine of x plus pi by 4. So now pi by 4 unit we have to translate on the left hand side. So minus pi by 4 we will start, because 0 minus pi by 4, and the extreme limit, right extreme limit will be 2 pi minus pi by 4. 2 pi minus pi by 4, which we can simplify it as 7 pi by 4. Okay, so graph will be nothing but the same. Okay, now you can also check this. This is a function of y is equals to sine x plus pi by 4. Now check at x is equals to 0. What is the value we are getting? X is equals to 0, we'll put sine pi by 4 means 1 by root 2. So this value is 1 by root 2. Okay. What is the maximum value we will get? We can get maximum value is 1 because the range, the maximum value of sine function is 1. Minimum value is minus 1. Right? So 1 we will get when this is, we will substitute y is equals to 1. So sine theta is 1 when theta is equals to pi by 2. So here we can write it equal to pi by 2. Okay, I'm just giving you a hint so that we can find directly x plus pi by 4 is equals to pi by 2 means x is equals to pi by 2 minus pi by 4, which is nothing but pi by 4. Clear? This part is clear? Any doubt? Now with that we will find out the graph of root 2 times sine x plus pi by 4. Okay, so now we will find the graph from minus pi by 4 to 7 pi by 4. Okay, so root 2 means what is, now here the function is converting from fx to kfx, because here now the function is same, only we are multiplying with root 2. So what will happen? The graph will enlarge or contrast vertically by k unit. Remember? So here k is already positive number, even though it is a greater than one value. That simply means the graph will enlarge only. Okay. So the maximum value will be now my plus root 2 and minimum value will be minus root 2. Remember, we have found out the range also. So here it will be minus pi by 4 and it will be here 7 pi by 4, and the graph now will be look like this. Sorry for the graph. Okay, so just understand the concept behind it. So now this maximum value is root 2 and this minimum value is minus root 2. Okay, what will be the value of this part? Y-intercept. Here y-intercept we are getting 1 by root 2 for this function. Now we have to multiply every value by root 2. So root 2 here multiply means root 2 y-intercept will be root 2 times of the initial function. So root 2 by root 2 means 1. So this value is now 1. And this value is same as pi by 4. This is 0. Clear? So now we have to find GIF of this function. I hope till now you understood. So this part is, I know, very much difficult question. I should say this is a lengthy question, not a difficult question, because we have learned this kind of concept in previous classes also. So in the next page, we'll find the GIF function, or I think we should find it here only. I'll use the different color. So now GIF means integer value. So we have to check only the y values of this function to get the GIF. Okay, because we have to find GIF. GIF means whatever value we are getting, we have to take GIF of it. Okay, greatest integer value of it. So now you can see from minus pi by 4 to pi by 4, we are moving from 0 to 1. Remember, we have to move upward to get the y value. So of 0 to 1, 0. So from pi by 4, we are getting 0. So we'll close it. And till up to open 0, we are getting open 1. Clear or not? At 0 exact, we are getting 1 only. So we'll what we will do, GIF of 1 is 1. So here we will draw point. Now we'll move again horizontally. So from 0 to pi by 4, what we are getting? Value 1 to root 2. What is GIF of 1 to root 2? Means value is greater than 1 but less than 2. So GIF will be 1 only. So here GIF is 1. Now we are dropping here from pi by 4 to this value. This value is we'll get, okay, so pi by 4 to where we'll get 1. So pi by root 2 to 1 value is root 2 to 1. Again root 2 to 1 value is again greater than 1. So GIF will be 1. So for this complete part we are getting one value only because we have to take GIF. So till this point we will get 1. So I have also closed it because at this point we will get exact 1. Exact 1 GIF is 1. So we have to find out this value because we have to check in which interval the function GIF is 1. Okay, so that we can substitute this GIF of this function as 1 only. Okay, so what we will do to find out this value, we will write the function value. So function value is equals to, we will write root 2 into sine x plus pi by 4 is equals to 1. So here 1 by root 2 it will become. So I'll remove and write here as 1 by root 2. 1 by root 2 means pi by 4 for sine. So x plus pi by 4 is equal to pi by 4. Or what can other value can we will get? With the symmetricity, we can also get pi minus pi by 4. If you remember the quadrant. Okay, so sine is positive in first quadrant and second quadrant. Okay, so this is first quadrant, this is second quadrant. By solving, we'll get x is equals to 0. And 3 pi by 4 minus pi by 4 means 2 pi by 4, which is pi by 2. So 0 we have already got here. At 0 we are getting 1. At pi by 2 we will also get 1. Clear? So similarly we have to find all the points where the function GIF is changing. Now from pi by 2 to this value we are getting value from 0 to 1 again. See, function is decreasing. Function value is 1. At pi by 2 open we are getting 1 minus pi by 2 plus we are getting 1 minus. So here we will get 0 and we'll move ahead, we'll again get 0 because GIF of any number less than 1 is 0. So till here we will get 0. So we'll put a hollow circle here. Okay, closed circle, sorry, closed circle here, not hollow. Okay, here it is hollow, here it is hollow, and here it is closed. Now we have to check again this value, at which value of x we are getting this value as 0. See, y value is 0 here. So we'll put a root 2 sine x plus pi by 4, root 2 sine x plus pi by 4 equal to 0. So root 2 I can remove directly because 0 by root 2 is 0. Okay, that means sine theta is 0. When sine theta is 0, when theta is equals to n pi. So x plus pi by 4 is equals to either 0 or pi. So x we are getting minus pi by 4 or 3 pi by 4. Minus pi by 4 you can see here we have already got minus pi by 4, we are getting 0 value. So that point will be 3 pi by 4. So in this interval pi by 2 to 3 pi by 4, the GIF of this function will be 0. Now again this is minimum value minus root 2, so somewhere we will be getting minus 1 also because minus 1 is bigger than minus root 2. Clear? So integer value we have to check now. So this is an integer value. So in this region, what is the value of GIF function? In this region, you can see this is a negative value and this is bigger than minus 1. So the value of GIF will be minus 1. If you remember, GIF of minus 0.25 is minus 1. Okay, so here we are getting negative value and also just above minus 1. So in this interval, we will be getting minus 1. So here I am going to put open circle because we have used here close. So open circle here to this part, we'll be getting minus 1. So at exact this point, we are getting exact minus 1. So GIF of this function will be minus 1. I'll put a closed circle here. Now I have to check what value of x is there in this interval. This is 3 pi by 4 again. And what is this value where we are getting minus 1? So it means this value is minus 1. Okay. So in the next page I'll write it down. root 2 sine x plus pi by 4 is equals to minus 1. So we are getting sine x plus pi by 4 is equals to minus 1 by root 2, or x plus pi by 4 is equals to minus 1 by root 2 we will be getting in the third and fourth quadrant. Sine theta is negative, third and fourth quadrant. So here you can see 1 by root 2. If I take magnitude only, so 1 by root 2 means pi by 4. Sine theta is pi by 4. Oh, sorry, theta is pi by 4 when sine theta is equals to 1 by root 2. So we'll be writing pi plus pi by 4, because in third quadrant we write pi plus theta, and in fourth quadrant we'll write 2 pi minus theta. So 2 pi minus theta. Theta is pi by 4 again. So here we are getting x is equals to pi by 4 cancel. X is equal to pi, and here pi by 4 and again minus pi by 4. So 2 pi minus pi by 2, which is 3 pi by 2. So we are getting again two values of x where function value is minus 1. So here function value is minus 1 at 3 pi by 4. Okay, and this value. What is this value we are getting? I think we have done some mistake, because 3 pi by 4, if you will put, this is pi. Okay, this is okay, sorry, this is 3 pi by 4. Sorry. So this value we have to find out. We have not found out. So we were getting two values, right? Pi and 3 pi by 2. So obviously this is pi and this is 3 pi by 2. And lastly, now in this region, you can see the value is below minus 1. Below minus 1, and this is somewhat around minus 1.4 root 2. Right? So this value is in the range of minus 1 to minus 2, and GIF of minus 1 to minus 2 to minus 1 is nothing but minus 2. Let's say, for example, GIF of minus 1.3. So that is minus 2. So it means in this region we'll be getting minus 2 value. So minus 2 value we had to extend it. Let's say we are getting minus 2 here. So in this region we'll put hollow circle here. Then we'll put here hollow circle. Okay, at this exact value we'll be getting minus 1, so this will be closed circle. Now after this, to this region we are getting a value lesser than 0 but greater than minus 1. So GIF of this value will be minus 1 again. So here we'll draw till up to this value, which is 7 pi by 4. We have already found out. Okay, and at exact 7 pi by 4 we are getting value is 0. So GIF of 0 is 0. So we have got all the intervals where we are getting GIF value. Okay, so now what we will do, we will finally find the integration. So we were getting 20 times 0 to 2 pi. So what we will do, we will now segregate every interval and find what is the GIF. So minus pi by 4 to 0 we were getting. So here we should write minus pi by 4. If you remember why I am writing minus pi by 4, because we are getting the value of this function. Okay, so minus pi by 4 to 7 pi by 4, the length of interval is again 2 pi. So we are getting all the values, what is the integration in this interval 2 pi, and we'll multiply 20 times for all the intervals. Okay, so minus 7 pi by 4 to plus 7 pi by 4. But again, I have to write 0 here, because in this case, what is the value we are getting? GIF is 0. So we'll directly write 0. Function is 0. I think now you got it. Okay, now plus. Now we'll start with 0 to which value we are getting 1. So here, if we move ahead, we are getting one value in which interval 0 to this value. This value is pi by 2. So we'll write integration 0 to pi by 2. The function value is now 1 again. 1. So we'll write 1 dx. Now we'll move ahead with pi by 2 to this point 3 pi by 4. What is the value we are getting? We are getting GIF is 0. So here we'll write from pi by 2 to 3 pi by 4 0 dx, right? Then pi by 3 pi, sorry, 3 pi, 3 pi by 4 we have written. Now 3 pi by 4 to this value is pi. What we are getting? Minus 1. So plus 3 pi by 4 to pi by, sorry, pi only. We are getting 1d minus 1, minus 1. See, the value is minus 1. So GIF of this function is minus 1 now. So we are directly putting minus 1. Now we'll start from pi. Now check from pi to which value this interval we'll be writing. This one. From pi to where? 3 pi by 2. What is the value of GIF? Minus 2. So we'll be writing minus 2 dx. Which interval? 3 pi by 2. So 3 pi by 2. And lastly, from 3 pi by 2 to 3 pi by 2 to this 7 pi by 4. What we are getting? Minus 1. So 7 pi by 4 minus 1 dx. Okay, so finally we'll write 20. Now 0, this is 0 because function is value 0. This is 1. So upper limit minus lower limit. So we'll write pi by 2. This is 0, so we can remove it. This is minus 1. So minus 1 into upper limit minus lower limit. So pi minus pi, 3 pi by 4 is pi by 4, but with a negative sign. So pi by 4. Now minus 2 times this minus this. This is pi. Okay. So 3 pi by 2 minus pi is pi by 2. And lastly, minus 1 times upper limit minus lower limit. So minus 1 times this is 6 pi by 4 we can write. So 7 pi by 4 minus 6 pi by 4 is pi by 4. Okay, so pi by 4 and pi by 4 club, because negative sign is there, will be cancelled out, plus pi by 2. Okay, and this is 2 and 2 cancel out, so we are getting 20 into minus pi, which is nothing but minus 20 pi. This was the very difficult question, and we should avoid it, this kind of question in exam. If it is taking more than 1 minute, then we should avoid this. Okay, so this was very tough question, I guess, in this paper. Now we have to check which option is correct. So for question number 66, minus 25 we were getting. So this option number B is correct. Okay, so I hope you learned all the concept till here. If there is any doubt, please let me know. Okay, so I'll wrap up this class right now. So all the best for your exam, and keep learning and keep solving the questions, okay, as much as possible. Okay, so all the best, and take sleep, good sleep. Okay, okay, then bye bye.